So there's a few new things to do in the lesson today. This concept's not really new, it's just the wording of it. In lesson 1.3, the first thing we're going to look at is discontinuity. Well, a function is continuous, a graph is continuous if you can draw it all the way along without lifting your pencil. If it's not continuous, then it must have a discontinuity or two in it. So there are, get off the screen. There are three types of discontinuity: an infinite discontinuity, a jump discontinuity, and a removable discontinuity. So write some notes on these. An infinite discontinuity happens if at close to a value of x, it could be any value, that it's x equals c, some number, at close to x equals at some number, the function goes off to plus or minus infinity. So this one here is an example of that, where here's your x equals c here, that was a c there, and at this point you can see the graph's got a vertical asymptote. And as you're approaching from one side, say the left, the graph is going down to negative infinity, and now just to the right of that line, the graph is going up to positive infinity. So that one is what we call an infinite discontinuity. Our next type is a jump discontinuity, and I think it's fairly obvious when you look at these pictures down here which of these has a jump in it. The definition of a jump discontinuity, this is a simplified definition. You work with something a little bit more complicated when you get to calculus. Okay, but a function has got a jump discontinuity if the function has different values of x as you approach a particular x value from the left and from the right. Let's look at this function here. So if we were approaching this function from the left, here's the left, we'd be going, and here's our value of c. As we approach this value of c, we'd be going down, 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 and just to the left, say that was, say c was 1. If you were at x is 0.999, your graph would have this x value. But if you were just to the right of x equals 1, if you were at x equals 1.1, your graph would have this value. There's a huge jump there. The function totally suddenly jumps from one function value to another. That's a jump discontinuity. On the left it has one function value, and as you're really close to that value of x, on the other side it's got a different one. So that's a jump discontinuity. And your final one is a removable discontinuity. They're sometimes called holes. The proper name is removable discontinuity. A function has a removable discontinuity if it looks like it would be a continuous line, but there's this one little hole just hanging out there at x equals a particular value. Okay, if that hole wasn't there, that graph would have looked like a straight line. It would have looked like it was continuous. Okay, so those are very, very simple. You just need to know the names. Infinite discontinuity, going off or down to, there'll be a vertical asymptote that's going to positive or negative infinity on either side of that asymptote. Jump discontinuity, it's obvious, it jumps from one function y value to another. And removable discontinuity, you just need to know it's called a hole. We're used to calling a hole. How do I get to my next page? Come on. Come on. Okay, here we go. This is, oh, we're having so much fun today. Okay, so increasing and decreasing. A function is increasing if, as you go, we say it's increasing on an interval, or decreasing on an interval, or constant on an interval. And what that interval will be two x values from, say, x1 to x2. So a function is increasing if, as you go between any two x values in that interval, as x gets bigger, as x increases, your f of x increases. Now, I know you want to call that y, but please, when we're in functions, call it f of x. So, for instance, on this graph, to find if you were going between one x value and a second x value, and your y values were getting bigger, you would have a slope that was going up like that. That's what increasing looks like. What decreasing looks like is just about the same definition. As you go between any two values of x on that interval, as you increase your x, your f of x, your y values decrease. So what that would look like would be going down from 1x to the next. Your function values have gone from that level down to that level. And what do you think constant means? As you go between any two x values on the interval, your value of y, your function value, does not change. It stays the same. So, how to do these questions? The easiest thing to do is just every single part of this graph is either increasing, decreasing, or constant. And the super thing is no points, no values are ever included, because you're always looking between two values, and your graph is, you never need to use square brackets, you just use parentheses. So let's start with the beginning of the graph. So this is x is -1, -2, -3, -4. That's x is -5. And this part of the graph, it's going down. So from x is -5 to -4, it's going down. So I'm going to write this interval by decreasing, -5 to -4. Sorry, my pen's not writing too nicely on this. I'm on my iPad and it's useless. Okay, the next part of the graph, from x is -4 to x is -3, it was going up. Yes, that's a negative. Then my next part of the graph, from this was x is -3 to -2, -1. Can you see that part of the graph is flat? So that's constant on that interval. You finish it off, pause your video, come back, and I'll just fill in the values quickly. Remember, the union is optional, and that is x is 0. Then the next part here, that part is going down from 0 to 2, and then it's going, this part it's going up, 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 and it's going to carry on going up. It looks like it's approaching a horizontal asymptote. It is going to carry on increasing, even though it looks like it's flattening off. It's slowly, slowly getting bigger all the time. So that was from x is 1, 2. That was x is 2 there. 2 to forever, to infinity and beyond. Right, so that was increasing and decreasing. Now for let's pause the video there and let's start a new video.